Chapter 1.2 Supply and Demand. The 2030 Agenda for Sustainable Development emphasizes the need to tackle global challenges, ranging from climate change to poverty, with sustainable food production a high priority. Brandy, 2017, UN 2017. As reflected in the UN Sustainable Development Goal 2, UN 2017, one of the greatest challenges facing the world is how to ensure that a growing global population, projected to rise to around 10 billion by 2050, will be able to meet its nutritional needs. To feed an additional 2 billion people by 2050, food production will need to increase by 50% globally, FAO 2017. Whilst more food will need to be produced, there is a shrinking rural labor force because of increasing urbanization, Dos Santos 2016. The global rural population has diminished from 66.4% to 46.1% in the period from 1960 to 2015, FAO 2017. Whilst in 2017, urban populations represented more than 54% of the total world population, nearly all future growth of the world's population will occur in urban areas such that by 2050, 66% of the global population will live in cities, UN 2014. This increasing urbanization of cities is accompanied by a simultaneously growing network of infrastructure systems, including transportation networks. To ensure global food security, total food production will need to increase by more than 70% in the coming decades to meet the Millennium Development Goals, FAO 2009, which include the eradication of extreme poverty and hunger, and also ensuring environmental sustainability. At the same time, food production will inevitably face other challenges, such as climate change, pollution, loss of biodiversity, loss of pollinators, and degradation of arable lands. These conditions require the adoption of rapid technological advances, more efficient and sustainable production methods, and also more efficient and sustainable food supply chains, given that approximately 1 billion people are already chronically malnourished, whilst agricultural systems continue to degrade land, water, and biodiversity at a global scale. Foley et al. 2011, Godfrey et al. 2010. Recent studies show that current trends in agricultural yield improvements will not be sufficient to meet projected global food demand by 2050, and these further suggest that an expansion of agricultural areas will be necessary. Bajzel et al. 2014. However, the widespread degradation of land in conjunction with other environmental problems appears to make this impossible. Agricultural land currently covers more than 1/3 of the world's land area, yet less than 1/3 of it is arable, approximately 10%. World Bank 2018. Over the last 3 decades, the availability of agricultural lands has been slowly decreasing, as evidenced by more than 50% decrease from 1970 to 2013. The effects of the loss of arable land cannot be remedied by converting natural areas into farmland, as this very often results in erosion as well as habitat loss. Plowing results in the loss of topsoil through wind and water erosion, resulting in reduced soil fertility, increased fertilization use, and then eventually to land degradation. Soil losses from land can then end up in ponds, dams, lakes, and rivers, causing damage to these habitats. In short, the global population is rapidly growing, urbanizing, and becoming wealthier. Consequently, dietary patterns are also changing, thus creating greater demands for greenhouse gas-intensive foods, such as meat and dairy products, with correspondingly greater land and resource requirements. Garnett, 2011. But whilst global consumption is growing, the world's available resources, i.e. land, water, and minerals, remain finite. Garnett, 2011. When looking at the full life cycle analysis of different food products, however, both Weber and Matthews, 2008, and Engelhaupt, 2008, suggest that dietary shifts can be a more effective means of lowering an average household's food-related climate footprint than buying local. Therefore, instead of looking at the reduction of supply chains, it has been argued that a dietary shift away from meat and dairy products towards nutritionally oriented agriculture can be more effective in reducing energy and footprints. Engelhaupt 2008, Garnett 2011. The complexity of demand-supply imbalances is compounded by deteriorating environmental conditions, which makes food production increasingly difficult and/or unpredictable in many regions of the world. Agricultural practices can not only undermine planetary boundaries, figure 1.1, but also aggravate the persistence and propagation of zoonotic diseases and other health risks. Garnett, 2011. All these factors result in the global food system losing its resilience and becoming increasingly unstable. Joyce et al. 2015. The ambitious 2015 deadline of the WHO's Millennium Development Goals to eradicate hunger and poverty, to improve health, and to ensure environmental sustainability has now passed, and it has become clear that providing nutritious food for the undernourished as well as for affluent populations is not a simple task. In summary, changes in climate, loss of land, and diminution in land quality, increasingly complex food chains, urban growth, pollution, and other adverse environmental conditions dictate that there is an urgent need to not only find new ways of growing nutritious food economically, but also locate food production facilities closer to consumers. Delivering on the Millennium Development Goals will require changes in practice, such as reducing waste, carbon, and ecological footprints, and aquaponics is one of the solutions that has the potential to deliver on these goals.